Ladies and gentlemen, today I'm going to talk about the issue of IEEE-based medical study standard. I'm the working group chair, Moon, and vice chair is Dr. Emily. This is the major model. We can obtain the model from the sectional images and make visualize like a realistic material. And finally, we can transfer the data from here to there and other practitioner or medical equipment company and even the patient and other researchers. Finally, the result material can utilize as the viewing and the diagnostic and the simulation and the printing. That's what I want going to do. And let's talk about segmentation first. It means first step of the modeling, obtain the data from the CT or MRI or other sectional images. Then in such an image, even though there is grayscale, but there is some kind of darkness and whiteness and brightness and the contrast difference. So following the structural difference of the structural difference of the signal, we can figure out the threat by the threshold method. Another way is just the nearby structure is regarded as same organ, so we can produce regional growing way. And another way of the segmentation is the shape difference, shape-based segmentation. The kidney is something like a bean, the heart something like the pear. So each the organ has a different shape. So following the pattern-based segmentation or morphology-based segmentation, the image obtained original mask from the CT, then we can enlarge or shrink following the structure, and additionally we can make a very simplified the structural difference, so-called fractal segmentation. If product is if we want bone modeling, the red one is we need this structure. The blue one is we want eliminate from the segmentation process. So you can produce this kind of simplified graphical method there, then we can obtain the data. And another version of the Monte Carlo, this manner is produce the structural, the point of the continuous structure such as our vessels and nerves and other structures. And for this process, we need to have normal and abnormal structure following the patient and normal patient. And let's move into visualization. At first, we can produce volumetric rendering material. Then we can produce this color-based difference, the lung and the vessels and the airways. Another way of the figure out for each structure is coloring. So the organ reveal different color and different translucent when you can see inside and the backside of the human structures. Yes, if we have a segmented the material, then we can make just segmented section, and additionally we can watch inside of the segmented material, and we can remain the structure and make translucent following our requirement. Yes, this is usefulness of our cloud-based treatment, the data management. We obtain the data from the CT, MRI, and SPECT CT, and can distribute to the student, the patient, and virtual reality material, 3D printing company, and human computer interaction. Finally, it is very, very useful for doctor and patient and researchers. That's our ambition for data management system. Yes, this is a way of simulation to obtain some airway system, where we are going to inside of the human airway. Then we can figure out and then we can detect each structure. The doctor can imagine which they encountering during this surgical procedure. Yes, and if there is some HMI system or other controller, then you can see inside from the patient CT data. My issue is showing this structure from the patient body and their inside of anatomy simultaneously. Yes, the final issue is 3D printing. Then the 3D printing can produce not only hard structure, now we can produce this soft tissue structure from the mold-based process, and the brain, and make translucent brain, reveal inside the tumor of in the human brain. And this is another the practical case. This patient has a bone tumor inside of patient leg, and before we decide the surgery, we need to decide cutting level for eliminate recurrence of tumor. And I'm sponsored by government for produce this 3D printing based the implant. Then we can put this implant into the human the bone. This is the synthetic material, and this is another human's bone. This is going to be 3D printing material inside the patient specific data. Yes, my slide again. We obtain the data from the CT and make visualize for more realistic, and we can do more the specific data the transfer system. Finally, we can produce 3D simulator and 3D printed material for patient care. Yes, this is my philosophy of producing the data and then useful for the doctor and the student and educational use. And finally, we can interact in between patient and doctor, and the result going and better and better.